Welcome to our new series from Pathfinder Arambha series. In this series, we are going to discuss the PYQs of JEE Main as well as JEE Advanced. This series is going to help you a lot. How it can help you, I'll tell you, because you will get a pattern how they are asking the questions. So before attempting your real examination, when you are going to the real battlefield, you need to exercise, you need to see how they are asking their questions, what are their patterns. So we are going to discuss the same questions which has been asked in previous JEE Mains as well as JEE Advanced. So let's start this series. Let's begin. So let's begin the series of this Arambha series from first question, which is pretty straightforward, and it's a very easy question, and it has been asked in JEE Main 2019. So I am reading this question out. A metal wire of resistance 3 ohm is elongated to make a uniform wire of double its previous length. This new wire is now bent and the ends joined to make a circle. If 2 points on this circle make an angle 60 degree to the center, the equivalent resistance between these 2 points will be. There are 2 key points here. First is elongated. First key point is elongated, and second key point is joined to make a circle. So now suppose there is a wire of length L. This wire is having length L and having cross section area, for an example, and you are making it twice. You are stretching it and you are making its length to twice its original length. So definitely when you stretch something, its thickness will reduce, right? So its area is going to change. Initial area is A. Now what will be its final area? For that, what is constant here? Volume. Volume is not changing here. So can we write here A into L? This is our initial volume. That will be equal to final volume 2L into A dash. From here, if you calculate A dash, it will become A by 2. So area will become half. So now, can we calculate the new resistance? Yes, R dash will be equal to rho, that is 2L divided by A by 2. So it will become 4 into rho L by A. And what is our initial resistance? Initial resistance is rho L by A. And what is its value? Its value is 3 ohm, which is given in the question. And what is its value? So its value will become 12 ohm. I hope it's pretty clear. Now, this is the first part of the question. Now, second part of the question is, now this wire is bent into the form of a circle. Now the circle, it is bent into the form of a circle, and you have to find out the potential difference across 2 ends. Sorry, equivalent resistance across 2 ends, A and B, which is making an angle 60 degree. It's clear? It's just like when we are calculating the equivalent resistance, you know, it is, let's connect a 1 fixed battery and let's try to observe this. This is a fixed battery. Let's try to observe this. If this is one resistance, for an example, and this is another resistance, its value is, for an example, R1 and its value is R2. So don't you see that these two are connected in parallel? You can see it, and you can just try to visualize. Don't you think that R1 and R2 are connected in parallel? It's having same potential difference, VA and VB, VA minus VB. So here, these two are connected in parallel. So we can reduce the circuit like this. This is your R1 and this is your R2. So our work is to find out this R1 and R2. How to calculate this R1 and R2? It depends on the length of the wire. Complete length is having a resistance 12 ohm. So 2 pi angle is having a resistance of 12 ohm. So let's see what will be the value of R1 for an angle 60 degree. So R1 will be equal to, can we write this value as theta by 2 pi into 12. Theta is pi by 3 divided by 2 pi into 12. And what is its value? Its value will come out to be 2 ohm. Right? So R1 is 2 ohm. So R2 will be definitely R1 plus R2 is 12. So R2 will be equal to 10 ohm. You can calculate and you can see also. If you want to calculate, you can see R2 value will be equal to theta. What is the value of theta? 2 pi minus pi by 3. So it is 5 pi by 3. It is 5 pi by 3. So 5 pi by 3 divided by 2 pi into 12. How much you are getting? You will get the value as 10 ohm. Or directly you can say R1 plus R2 is 12 ohm. So definitely R2 will be 10 ohm. So this one is 2 ohm. Now this one is 10 ohm. So can you calculate the R equivalent? Very easy. So R equivalent, when two resistances are connected in parallel, you can directly calculate by using this formula R1 R2 divided by R1 plus R2. What is the value of R1? 2. What is the value of R2? It is 10 divided by 12. So it will come out to be 5 by 3 ohm. So what do you think? This question is tough? No, it's very easy. You need to practice. So this is your first question. Let's move to our next question of this Arambh series. So next question is this one. See the question. You can pause the video and you can attempt this question by yourself. In the circuit shown, the potential difference between A and B is. What is the potential difference between A and B? So here, you can, what is the key point here? Key point is this A and B are open ends. So across the open ends, current will not flow. There will be no current across this ends. So current will not be there. So here current will not flow. I will be equal to 0. And in this ends also, I will be equal to 0. No current will flow. So if no current will flow, can we say the potential across A and this point will have the same potential? So can we say, suppose this D, can we say potential across A will be equal to potential across D, since no current is flowing across this wire? And potential across B is equal to potential across C. Alright? Clear. Now, if we are able to find out the potential across C and D, we will get the answer, right? Because we have to find out the potential difference between A and B. Now, how to proceed? In this case, can we consider this circuit? Just see this circuit. This is a question of a mixed grouping, where the batteries are connected in parallel and they are having an internal resistance 1 ohm, 1 ohm and 1 ohm. And when these batteries are connected in parallel, having some internal resistance, then you know this formula, E equivalent divided by R equivalent will be given by E1 by R1 plus E2 by R2 plus E3 by R3. Is it clear? Now R equivalent you can calculate easily. What is the value of R equivalent? From here 1, 1, 1. So its R equivalent will be equal to 1 by 3. Now just put that value. So E equivalent divided by 1 by 3, sorry, 1 by 3 ohm is equal to E1 value is 1 volt, 1 by 1 plus E2 is 2 volt, 2 by 1 plus E3 is 3 volts. So 3 by 1. So basically how much we are going to get? 3 E equivalent, that is equal to 3 to 5 plus 1, 6. So E equivalent will be equal to 2 volt. That means across these two ends, the equivalent potential difference is 2 volt. So can we say VA minus VB, that will also be equal to 2 volt? That's the key point. And this is your answer, 2 volt. Option number C is correct. Clear? Fine. So let's move to the next question of Arambh series. Let's move. Now, next question is, in the given circuit diagram, when the current reaches steady state in the circuit, the charge on the capacitor of capacitance C will be. In this case, what is the key point here? Key point here is steady state. What do you mean by steady state? If you know this, when the capacitor is fully charged, when this capacitor is fully charged, in that case, it will not allow current to pass through it, right? So current across this R1 is 0 when in steady state. And you know that at t is equal to 0, when just current is started to, suppose if we put one key here, in that case, at t is equal to 0, this capacitor will behave as a conductor. Okay, so these two key differences are there. You should note it down. Now, in this case, R1 has no any role to play. First, if we are able to calculate the potential difference across this point, this is how you can frame, this is how you can reach to the solution. You have to frame how to reach to that point. So, if we are able to calculate the potential difference, अगर potential difference मिल जाए इन दोनों points के end में, तो क्या चार्ज निकालना इजी हो जाएगा? Q is equal to CV. Correct. So हमारा फोकस होना चाहिए पोटेंशियल डिफरेंस निकालना किसके अक्रॉस दिस रेजिस्टर, बिकॉज वही पोटेंशियल डिफरेंस होगा अक्रॉस दिस कैपेसिटर. क्लियर? नाउ इन दिस केस व्हाट वी आर गोइंग टू डू, फर्स्ट वी आर गोइंग टू कैलकुलेट द करंट I, and I will be equal to, simply it's a, if you remove this circuit, it is a R and R2 are connected in series having EMF E, so E divided by R plus R2. Clear? After getting the current, what is the potential difference across R2? VR2. The potential difference across R2 will be given by I into R2. Clear? And what is the value of I? It is E divided by R plus R2. I hope up to here it is pretty clear. It's clear, right? Now let's move to the next step. Next step, after getting this potential difference across this R2, it is the same as potential difference across the capacitor. So charge on the capacitor will be given by C, capacitance multiplied by the potential across R2. So C is C and potential is E. You can write R2 divided by R plus R2. Right? So this is your answer. So option number C, option C is correct. Now you can just, even if you don't know the process, you can eliminate the answer, you can reach to this solution. How you can eliminate the answer? Because this is also going to help you in examination. जब टाइम कम हो तो एलिमिनेशन मेथड भी वर्क करता है. कैसे? सबसे पहली बात, तुम जब ये R1 का कोई रोल ही नहीं है तो ये R1 आंसर में आएगा ही नहीं. और सबसे पहली बात कि जब ये कैपेसिटी, इसका टोटल ईएमएफ ई है, तो कुछ तो पोटेंशियल ड्रॉप यहां पे करेगा, कुछ तो पोटेंशियल यहां पे ड्रॉप करेगा. जब कुछ पोटेंशियल ड्रॉप करेगा तो इन दोनों पॉइंट पे पोटेंशियल डिफरेंस क्या सीई होगा? बिल्कुल नहीं. दिस ऑप्शन वी कैन नेग्लेक्ट. और वैल्यू R1 पे डिपेंड नहीं कर रहा है तो ये वैल्यू भी आंसर में नहीं होगा और ये भी नहीं होगा आंसर. सो ओनली वन ऑप्शन इज करेक्ट, विच इज ऑप्शन सी, विच यू कैन रीच टू विदाउट सॉल्विंग दिस एंटायर क्वेश्चन. That's all. So let's move to the next question of this Aram series. Now this question has been asked in JEE Main 2015. Right? Let me read out the question. In the electric network shown, when no current flows through the 4 ohm resistor, there is no current flowing across this 4 ohm resistor in the arm EB. The potential difference between the points A and D will be. So basically you have to find out the potential difference between these points. You have to find out the potential difference between, sorry. Yeah. So between this point A and this point D, right, and no current is flowing across this. I'll give you two methods. So both the way you can just reach out to the solution. You can start by this. Let's start from C and let's reach to D. I'm starting from C and I'm going in this direction. So can we calculate VC minus VD? Or you can write it like this. Use the KVL in this from C to D. Use KVL in C to D. VC, okay, it is positive. It is going from positive terminal towards negative terminal, so it will be negative. So minus 3. Then again it is plus 4. No current is flowing across here. Minus VD, that is equal to 0. I am using KVL here. So यहाँ से KVL use करने के बाद क्या मिलेगा? VC minus VD, that is equal to minus 1. Now let's come to this. Let's proceed from A to C. यहां से ऐसे जाते हैं. अब यहां से ऐसे फ्लो करते हैं. A से C की तरफ ऐसे जा रहे हैं. So can we calculate VA? यहां से ऐसे KVL यूज कर रहे हैं A to C. So VA पॉजिटिव हो गया, माइनस 9 वोल्ट. देन यहां प्लस 3 वोल्ट माइनस VC इज इक्वल टू 0. करेक्ट है. सो यहां से VA माइनस VC का वैल्यू क्या आ जाएगा? माइनस 9 प्लस 3, माइनस 9 प्लस 3 दैट इज 6. सो यहां पर आ जाएगा 6 वोल्ट, यहां पे माइनस 1. क्लियर है? इज इट क्लियर? नाउ दिस इज योर इक्वेशन नंबर 1, this is your equation number 2. Just add this. VC will be cancelled out. So after adding 1 and 2, adding equation 1 and 2, what you are going to get? VC will cancel out. So you will get VA minus VD, which is equal to 6 minus 1, that is 5 volt. This is our option number C. It's correct. Now there is one easy way to solve this one. I'll discuss that method also. This is one of the method, traditional way. You can use the KVL and you can solve it. अब easy कैसे, जब टाइम कम है तो कैसे सॉल्व करेंगे? सिंपल, ये तीनों कनेक्ट है. यहाँ पे मान लेते हैं इसका पोटेंशियल 0 है, ये 0 पोटेंशियल पे है, तो ये कितना पोटेंशियल होगा? 4. ये उसका पोटेंशियल हो जाएगा 4. ये 0 है तो यहाँ पे पोटेंशियल कितना आएगा? ए पे 9 वोल्ट. ठीक है. और देखो ये 0 है, ये 4 है, तो यहां पे भी 4 होना चाहिए, यहां पे भी 4 होना चाहिए. क्यों 4 होना चाहिए? क्योंकि यहां पे करंट नहीं फ्लो हो रहा. I इज इक्वल टू 0 है. सो करंट अगर नहीं फ्लो हो रहा है तो इस E का पोटेंशियल और इस पॉजिटिव टर्मिनल ऑफ द बैटरी का पोटेंशियल दोनों सेम होना चाहिए. सो यहां पे हो गया I इज इक्वल टू 0. ये भी 4 वोल्ट है तो यहां D क्या 4 वोल्ट होगा. अब देखो VA माइनस VD क्या आ जाएगा? VA माइनस VD क्या 9 माइनस 4 आएगा? 5 वोल्ट, 1 लाइन. दैट्स इट. क्लियर? नाउ you can, if you are not having a time, you can use this method also, or you can go through the traditional method as well. Now let's move to the next question of this series. Yeah, let's see some question based on the graph. Now in this question, suppose the drift velocity Vd in a material varied with the applied electric field E, as Vd is proportional to root E. Then Vi graph for a wire made of such a material is best given by. So you have to draw the Vi curve where the relation is given with the drift velocity Vd सो रिलेशन गिवन है Vd ड्रिफ्ट वेलोसिटी और इलेक्ट्रिक फील्ड में रूट ओवर E. क्लियर है? बट ग्राफ ड्रॉ करना है V और I में. सो करना क्या है? तो यहाँ पे रिलेशन फाइंड आउट करना पड़ेगा V और I में. Do we have a relation with VD and current? Yes. What is that relation? We know that I, current across a conductor, is given by NEA VD. Clear? Current across a conductor will be given by NEA VD, where N is the number of electrons, E is the charge on an electron, A is the cross sectional area, and VD is your drift velocity. Can we say from this relation I is proportional to VD? Okay, we got this relation, so we can replace this relation by this one. I is proportional to root over E. Fine. Now again, do we have any relation between electric field and potential? Electric field और potential में कोई relation? Yes, we are having that. कौन सा relation है? E is equal to V by L. So यहां से क्या मिल जाएगा? अगर L length of the conductor is constant, so we will get E is proportional to V. Electric field क्या होगा? Voltage के proportional, potential difference के proportional. So can we write from here? यहां से क्या लिख सकते हैं? I is proportional to root under V. बिल्कुल. तो क्या यहां से थोड़ा सा रिलेशन को मॉडिफाई कर लें? So I square is proportional to V we are getting. Okay. Now if you remember the graph of a parabola, so y square is equal to 4x. This is the standard equation of a parabola, right? Now in this case, what is in the y-axis? V is in the y-axis. And what is in the x-axis? I is in the x-axis. So here, this graph, can we write it as x square is equal to 4ay? This is the standard equation of a parabola where the graph will be like this, correct? But here, x is I is in the x direction and V is in the y direction. So here, the graph will be a parabola which is like this. This is the graph of a x square is equal to 4ay. So definitely this will be your correct answer. So option number C is correct. Okay, so I hope this you can attempt some more question based on the graph. Just try it, don't skip, because the graph questions are relatively easy and it will give you 100% marks. Let's move to the next question. Next, this is also a very easy question, so let's see it. It has been asked in JEE 2014. In a large building, there are 15 bulbs of 40 watt, 5 bulbs of 100 watt, and 5 fans of 80 watt, and 1 heater of 1 kilowatt. The voltage of the electric mains supply is 220 volt. The minimum capacity of the main fuse of the building will be. Fuse जो लगाते हैं, fuse क्यों लगाते हैं? To protect. अगर sudden कोई current आ रहा है, sudden increase of current हो रहा है, तो उस डिवाइस को प्रोटेक्ट करे. तो फ्यूज का मिनिमम कैपेसिटी क्या होना चाहिए? मिनिमम कैपेसिटी मींस अगर फ्यूज को जितना करंट नीडेड है, अगर उसका वैल्यू उससे कम होगा तो वो ब्लोन आउट हो जाएगा. तो योर सर्किट इज योर ऑल दिस apparatus is not going to work. So इस केस में एक बिल्डिंग में कितने बल्ब है? 40 वॉट के 15 बल्ब है. सो टोटल कितना पावर का कंजम्पशन हो रहा है? लेट्स सी इट. Let's see the total power consumption in this building. So total power consumption, P total. So total power consumption is 15 bulbs having 40 watt, 15 into 40, plus 5 bulbs of 100 watts, so 5 into 100, plus 5 fans of 80 watt, so 5 into 80, and 1 heater of 1 kilowatt. 1 heater of 1 kilowatt means 1000 watt. So this much of power is needed. So total 15 into 40, that is 600, plus 5 into 100, 500, plus 80 into 5, that is 400, plus 1000. How much it becomes? 1000 plus 1000, 2000. So it will become 2500 watt. This is the requirement. This is the power requirement in this building. Now, you know this formula, power is equal to VI, 2500. And so I will be equal to 2500 divided by, I think voltage is given, right? Yes, it is given 220 volt. So divided by 220. So just divide it. Approximately how much you are going to get? Approximate value will be 11.3 amp. Approximate value will be 11.3 amp. You can check it. So your value, that means the fuse, should not be less than this. Should not be less than this. So this value is cancel. This value is also, you cannot make a fuse. So answer will be C, because they have asked minimum capacity of the main fuse. So 12 ampere will be your answer. Next. So very easy question. Let's move to the next one. Yes. So one question we have taken from JEE advanced section. As promised, I have told you a few questions I'll take from mains and few questions I'll take from advanced. Okay. So you can see in the circuit shown below, the key is pressed. At time t is equal to 0, which of the following statement is or are true? Multiple choice question it is. Maybe only one options are correct, maybe none of the options are correct, maybe all the 4 options are correct. So we need to check each and every options whether it is correct or not. And it's a very important question. I hope you are aware about the RC circuit. Let me just brief you about. So if a capacitor is there and one resistance is there and it is connected with a battery, so this circuit is called as RC circuit. In this few things that we are going to mention, suppose it is having EMF E. First thing, charge I am going to write Q is equal to Q naught 1 minus e raised to minus t by tau, and I is equal to I naught e raised to minus t by tau. Clear? So this is the relation with the charge and this is the relation with the current in the RC circuit. And one more thing, time constant tau. How to calculate the time constant? So I'm doing it in the beginning, starting of the question. Time constant you can calculate tau. Just short circuit the battery. That's how to calculate the time constant. Just short circuit the battery and calculate the R equivalent across this capacitor. R equivalent across this capacitor. So here it will be R only multiplied by capacitance RC. So this is your time constant. And if more than multiple resistances are connected, then you can use this method, shorting the battery, and then you can calculate the tau equivalent. In this case, it will be RC. Now the question is, here 2 RC circuits are there. One is this one and one is this one. 2 RC circuits. Treat them as a separate RC circuit. 2 different RC circuits. So what I am going to do, I am going to treat this upper half as one RC circuit, ऊपर वाले को एक अलग RC सर्किट में ट्रीट करेंगे और नीचे वाले को एक अलग RC सर्किट में ट्रीट करेंगे, और ऐसे हम लोग क्वेश्चन पे प्रोसीड करेंगे. ठीक है? सो लेट्स सी. Voltmeter displays -5 volt as soon as the key is pressed and display +5 volt after a long time. उससे पहले एक और काम कर लेते हैं. Let's finish one work. Can you calculate, अगर मैं इसको ऐसे ड्रॉ करूं, इस सर्किट को, इसको मैं हटा दे रहा हूं. I am drawing this circuit like this. Sorry. यहाँ पे कैपेसिटर, यहाँ पे एक रेजिस्टर, यहाँ पे एक रेजिस्टर और यहाँ पे एक कैपेसिटर। इसको मैं ऐसे ड्रॉ कर रहा हूँ और ये कनेक्टेड है एक बैटरी से विच इज हैविंग 5 वोल्ट। बोलो सही है। और यहाँ पे एक की लगा हुआ है, छोटा सा की लगा देता हूं, की लगा, ठीक है। और इसकी वैल्यू है 25 किलो ओम और इसकी वैल्यू है 50 किलो। ये कैपेसिटर है 20 माइक्रोफैराड और ये कैपेसिटर है 40 माइक्रोफैराड। अब इन दोनों को हम अलग अलग आरसी सर्किट में इसलिए ट्रीट कर सकते हैं क्योंकि देखो अगर ध्यान से देखो तो अदर ऊपर वाला जो सर्किट है और नीचे वाला सर्किट है, क्या वो इंडिपेंडेंटली बैटरी 5 वोल्ट से कनेक्टेड है? दोनों इंडिपेंडेंटली करेक्ट है, इसका कोई रोल नहीं है इसके टाइम कांस्टेंट में। तो इसका एक पहले टाइम कांस्टेंट कैलकुलेट कर लेते हैं ऊपर वाले का टाइम कांस्टेंट हम τ1 लिखते हैं, नीचे वाले का τ2 लिखते हैं। सो टाइम कांस्टेंट τ1 का वैल्यू क्या हो जाएगा बताओ? ऊपर वाले को, नीचे वाले को भूल जाओ, एकदम भूल जाओ नीचे वाले। तो बैटरी को शॉर्ट करना है, इसका निकालना है, क्या ये आ जाएगा R1C1, R1C1 का वैल्यू, R1 है 25 इंटू 10⁻³ एंड C1 का वैल्यू है 40 इंटू 10⁻⁻⁶। सो इसका वैल्यू आ जाएगा आफ्टर सॉल्यूशन, इट्स वैल्यू विल बी 25 इंटू 40 इंटू 10⁻³ दैट इज 10⁻⁶ इंटू 10⁻⁻⁶ दैट इज इक्वल टू 1 सेकेंड। सिमिलरली अगर तुम निकालोगे τ2, सो τ2 व्हेन यू कैलकुलेट तो भूल जाओ ये ऊपर वाला सर्किट, सिर्फ नीचे वाला सर्किट को देखो। तो क्या हम इसको लिख सकते हैं 50 इंटू 10⁻³ इंटू 20 इंटू 10⁻⁻⁶, करेक्ट है। और इसका वैल्यू भी अगर तुम कैलकुलेट करो तो इट विल कम आउट टू बी 1 सेकेंड। क्लियर है यहां तक? ये वैल्यू जस्ट नोट इट डाउन एंड आफ्टर दैट लेट्स सी द क्वेश्चन। द क्वेश्चन इज इजी। द वोल्ट मीटर डिस्प्लेस -5 वोल्ट एज सुन एज द की इज प्रेस्ड। अच्छा, ये बैटरी का भी एक सिग्निफिकेंस है, इस सॉरी वोल्ट मीटर का भी एक सिग्निफिकेंस है। क्या सिग्निफिकेंस है ये प्लस और माइनस का? कि ये हमेशा जो मेजर करेगा, अगर इसका पोटेंशियल मैंने VA लिख दिया और इसका पोटेंशियल अगर मैंने सपोज VB लिख दिया, तो ये हमेशा क्या मेजर करेगा? VA माइनस VB मेजर करेगा, ठीक है। ये प्लस और माइनस साइन का ये सिग्निफिकेंस है, इट विल ऑलवेज मेजर VA माइनस VB, ठीक है। नाउ लेट्स सी, अब यहां पर as soon as key is pressed, जैसे ही तुम की को प्रेस करोगे at t is equal to 0, what is gonna happen? At t is equal to 0, यहां पे मैं कर दे रहा हूं, at t is equal to 0, what is gonna happen? ये कैपेसिटर क्या एक वायर की तरह काम करेगा, इट विल एक्ट एज अ कंडक्टर। अब जैसे ये कंडक्टर की तरह काम करेगा, यू हैव टू कैलकुलेट द पोटेंशियल अक्रॉस दिस VA, दिस इज योर पॉइंट A एंड दिस इज योर पॉइंट B, सो कैलकुलेट द पोटेंशियल अक्रॉस दिस VA। सो लेट्स मूव, किसी भी डायरेक्शन में मूव कर लो, किधर मूव करना चाहोगे, ऐसे मूव करते हैं। चलो थोड़ा सा कलर चेंज करके इसको ऐसे मूव करते हैं, ऐसे मूव करते हैं, ऐसे मूव कर रहे हैं, देखो ऐसे मूव कर रहे हैं और यहां पहुंच रहे हैं, ठीक है। तो जब ऐसे मूव करोगे, ये तो कैपेसिटर तो काम कर रहा है एज अ कंडक्टर, तो यहां इसका कोई रोल है नहीं, वो कंडक्टर बन गया। यहां से माइनस से प्लस, सबसे पहले लिखो VA, सबसे पहले लिखो VA, ठीक है। ऐसे मूव कर रहे हैं, ऐसे मूव कर रहे हैं, यहां पे आया माइनस टू प्लस -5, ठीक है। देन लेट्स मूव इट इन दिस डायरेक्शन। बैटरी का टर्मिनल कनेक्टेड है 20 माइक्रोफैराड, ठीक है। यहाँ पे 25 किलो ओम सही है, 50 किलो ओम सही है, 40 माइक्रोफैराड करेक्ट है, ठीक है। सो यहाँ पे बैटरी हो जाएगा +5 वोल्ट और ये यहां से फिर यहां पे पहुंचा -VB, क्या इसका वैल्यू 0 के बराबर होगा? सो यहां से VA माइनस VB का वैल्यू क्या आ गया? VA minus VB is equal to minus 5 volt. So first option, this is minus 5 volt. Yes, we are getting minus 5 volt. We are getting minus 5 volt. So now can I remove this section? We have to check for whether we are getting plus 5 volt or not when it is pressed for a longer period of time. So I am just wiping it up. So let's move to this next section. I hope this part is clear. So I'm moving to the next part. So VA minus VB, we are getting it as minus 5 volt. Next, see, next how to proceed. I will draw it fresh. Again, new drawing. For the second part, for plus 5 volt. So I'm removing all the sections. I hope you remember all the values, tau 1 and tau 2. Again, I am drawing the new diagram. Now, after a long time, this is 40 microfarad. This is 20 microfarad. And this one is 50 kilo ohm. And this one is 25 kilo ohm. So after a long time, what is going to happen? This is 5 volt. This will act as an insulator. No current will flow through it. So here, suppose here the charge is Q1. Here it will be minus Q1. Here the charge is Q2. In this it will be minus Q2 in this plate. Correct? And there will be no current. So if there is no current, let's move it. Let's use the KVL in this direction. Let's use it. So I will traverse along this path. Just see how I am traversing. I am traversing along this path. And I am reaching to this point. Clear? I am traversing along this path. So when I am traversing along this path, let's start with A. Can we write VA, since no current is flowing, I is equal to 0. I is equal to 0. No current is flowing in the circuit. So here no potential drop. Here it is minus 5 volt. And again here it is 0. So minus VB, that is equal to 0. So how much you are getting? VA minus VB, that is equal to 5 volt. That is equal to 5 volt. Is it clear? So option number A is our correct option. From where we are getting? When we press the key for a longer period of time, then there will be no current in the circuit because the capacitor is fully charged in this steady state. So in this case, VA minus VB, we will get it as plus 5 volt. So that is the correct option. Now the voltmeter will display 0 volt. Now voltmeter will display 0 volt at time t is equal to ln 2 seconds. Clear? So here, how to proceed? So let's remove this. Now let's see. So I am removing this because so many diagrams are being drawn here. Fine. Third one is the second one. The voltmeter will display 0 volt at time t is equal to ln 2 seconds. So t is equal to ln 2 seconds. It will display. Again, I'll come to that same methodology. Here one resistance, here one capacitor, here one capacitor, and here one resistance. Only traversing matters. This is 5 volt. Right? From this is your A and this is your B. So let's traverse. Which direction you want to traverse? Let's traverse it along this direction. This is having 20 microfarad and this is having 40 microfarad and this is 50 kilo ohm and this is 25 kilo ohm. Again, let's traverse along this direction. So let's do it. VA minus VB is equal to, what is the charge across here? Oh. Can we write here? VA minus VB is equal to, this one is Q2, right? Here we have drawn it as a minus Q2. If you remember, this one is Q2. So can we say Q2 by C2 minus I1 R1. Just see. Clear? Now Q2 by C2. What is the value of Q2? Q2 can we write it as Q2 is equal to Q into total current, total charge 1 minus e raised to minus t by tau. They are asking at time t is equal to ln2 seconds. So let's see, put that value. So Q2 is equal to, can we write it as C2 E divided by C2 into 1 minus e raised to minus t by tau. What is the value of tau? It is 1 second. So we can write tau as 1 second minus this value. Can we write I naught into e raised to minus t? Can we write into R1? And what is the value of I naught? So what is the value of I naught? I'm just writing it here. So here the equation reduced to VA minus VB is 0 because the voltmeter reads as 0. So VA minus VB is equal to 0. So here we can write, here C2 and C2 will cancel out. So E into 1 minus e raised to minus t, and here minus I naught, what we can write? E divided by R1. E divided by R1, and here it is e raised to minus t R1. So this R1 and R1 will cancel out, and here finally what you are going to get? Here you are going to get it as E is 5. 5 you can cancel it in that direction. 1 minus e raised to minus t minus e raised to minus t is equal to 0. So from here 2 e raised to minus t is equal to 1. So e raised to t will be equal to 2. So t is equal to ln 2 you are going to get. T is equal to ln 2. So at what time the potential difference across the voltmeter is 0? It is ln 2. So at ln 2 time the voltmeter will display 0 volt. So option number 2 is also correct. Clear? Now let's move to the third option, that is the current in the ammeter becomes 1 by E of the initial value after 1 second. It's you know that after time constant, after tau second, the current in the ammeter, after tau second, what is the value of the current? After tau second, the value of the current will be I is equal to, you know that the value I is equal to I naught e raised to minus t by tau. So after tau second, that means when t is equal to tau, which is equal to 1 second, which is equal to tau. So when t is equal to tau, the current will become I naught by E. Yes or no? And why I am writing only one? Because both are having the same time constant. So it is true for both of the circuits. So total current will be I naught by E plus I naught dash by E. You can write. So ultimately it will become I naught by E. So third option C is also correct. And fourth option, the current in the ammeter becomes 0 after a long time. This one is clear, no? How we got this one? If you want, suppose let us assume this is having I1 current and this is having I2 current, right? For an example. So I1 value will be equal to, suppose I am writing I naught dash, this is the maximum current in the upper half of the circuit. that is equal to e raised to minus t by tau. Now tau is 1 second, this one is also 1 second, so here I1 will be equal to, after t is equal to 1 second, we will get it as I naught dash by E. Clear hai? Similarly for the I2, for the second circuit, we will get I2 is equal to I naught double dash, for an example, divided by E. Can we write? So I1 plus I2 you can write I naught dash plus I naught double dash, which is equal to I naught. So this value is we are getting. So C is also correct. Now next D, the current in the ammeter becomes 0 after a long time. So let's remove this and let's see. I hope this part is clear. So this is a very good question. Now let's see the last question. Last question, just logically you can answer. There is no need of any pen and paper over here. The current in the ammeter becomes 0 after a long time. After a long time, what will happen? After a long time, this capacitor will start acting as a insulator. After a long time, it will be fully charged. So both of them will start acting as a insulator. So there will be no current. I will be 0. There will be no current in the circuit. If there is no current in the circuit, definitely this ammeter is going to show 0 current. This ammeter is going to show a 0 current after a long time. So this option is also correct. So all the 4 options A, B, C and D are correct. So if you are going to mark all these 4 options, you are going to get the full marks. So this is the approach you should follow while attempting any JEE mains or advanced question. So next, again we are going to continue this series in the upcoming next week. Tune into Pathfinder channel for more such type of content, and definitely we are going to meet again. Thank you. So I hope you don't have any doubts in this session. So let's wind it up, and let's all the best for your preparation, and hope you are doing very nice and you are preparing very hard for the upcoming examination. So that's it. Thank you for joining our Pathfinder channel.